In this video, let's talk about the stack implementation using arrays. So before going further, let's understand properly the problem statement. So stack means it is basically having the LIFO condition. So it means there will be a restrictive search. So a restrictive access. And coming to arrays, it is basically a static memory. It will be having a static memory. And also for arrays we can have a random access. Blending stack by using arrays means we'll be having a limited access. We need to follow the LIFO condition, and as we are using the arrays we'll be having a static memory, not dynamic. So what do you mean by static means the memory is fixed. If you are using let's say array of size 5 means we'll be having 5 into 4 20 bytes. So the size is fixed, we can't change it anymore. So this is the fundamental things about this problem statement. Also there is one more point, that so what are the operations or stack implementation operations which we can perform are: one is push we can perform, one is pop we can perform, one is top, or it is also known as a peak, and other is display. Also we can perform other operations like search, etc. So now let's continue with writing of program. So first let's having these libraries. Let me define the size of array. Let's say the size of array, I will be putting it as max 5, and I will be continuing with void main. Void. And also I will initialize the top to 5, top to -1. So we know how the stack will be. This is how the stack will be. As we said, it is the size is 5 as with this statement. So it will be having the indexes like 1 0 1 2 3 4. So it will be having a 4 index. So int top is equal to -1. Top is equal to -1 means so there is no element which was inserted. So initially we'll be initialize top to -1. Initialize top to -1 as no element present in stack. And next thing, so we can have a various we can use various switch cases. Like I will be writing in this way: switch choice. So printf enter choice, scanf %d and address choice choice. I will be also declaring as int choice. Okay, so with switch case what I will be doing is, so I will be also writing it in the while loop. So while switch case, so if I press 1 means it should to be doing the push operation, and why I am writing this break means it will be come out of the switch. So next case 2. So if I put if I enter the if I enter 2 means I will be using the pop operation. So before it I think I should be writing this thing. printf. So after while I should be, otherwise I will do one thing. So while one printf, so 1 for push /n, or I can simply put a /n or /t, anything is fine. Next to 2 means pop, 3 means peak, 4 means display, 5 means search. So I will be writing /n. Fine. So yeah, I think I should be also writing it in the while loop, this statement. And after displaying it, so basically enter choice /n scanf %d choice. Yeah, now it is fine. So basically, yeah, first all these five operations will be printed and we will be choosing one choice. So based upon that, we are writing the switch case, so which we will be selecting a particular operation to perform on the stack. Next, if I press 3 means I should be doing the peak operation. Next, if I print 4 means I should be going to the display operation. If I press 5 means, fifth choice means I will be performing some search operation. And also we can add something like 6 means exit. So if I press 6 means it will be exit. So if I press any number other than this, then I should be writing in this way: default any number other than this means it will be print like, so enter correct choice. So we are closing for the switch, closing for while loop, will be closing the bracket for main loop. So this is the main loop, and then we will be writing for one by one. We'll be writing the logic program for one by one operation. So firstly we'll write for push. So void push means firstly I should be taking some data from the user to add it into the stack. So this is the stack. Let me put like int x, printf enter data to insert to stack, scanf %d $x. So we'll be entering the data. So if there are two possibilities, if if already the stack is full, then we can't add we can't push any data element into the stack. So we need to firstly confirm it. So if top has reached the max size, means if top already reached the fifth, so 0 1 2 3 4, we took max as 5, right? So if top has reached this level means, then when we are trying to push, it should be printing like so, stack overflow condition, so can't push data element into stack anymore. If it is not the case, then we can happily insert any element. So how we can insert? So initially also I think we should do one thing, because we did not declare the stack array anywhere. So for that, what we need to do is, so I will be initializing it globally int s. Let's say the stack is kind of array right here, so s of max I will be taking. So I am declaring, so all the elements in the stack are now of type integer only. If we put here float means all the data which we enter into the stack will be of float format, float data type. Okay, so now, so if it is the else condition, we'll increment the top and then we'll insert the element. So s of top is equal to x. So now what is happening here means, let's say we have already 10, 20. Now the top will be here. Now I want to insert the data 30 here. So what I will be doing, so I will increment the top initially and I will insert this value. So s of top is equal to x means the 30 will be inserted. So this is the push operation, and now we will be trying with pop. So void pop, so pop means deleting, push means inserting. So void pop. So firstly we need to check one condition. So for deletion there should be some elements to delete. If there are no elements that is present, then it is an underflow condition. So first we need to check that condition. If top is equal to -1, printf underflow condition, that is no element is present currently in stack. If it is not the case, if at least one is present, at least one element is present, then what we can do, simply we can make that s of top, that element as 0, and we can decrement the top minus is equal to 1. So instead of this we can also write this way, top is equal to top minus 1, or simply we can write top minus is equal to 1. So I have decrease. So for example, let's say initially there is 10 and there is 20. So currently top is here. So if I use the pop operation means, so this topmost element will be deleted. So what I'm doing, s of top, I am making it 0 and I am decrementing the top. So currently top is here. So this is what I am doing here. So this is about the pop, and next operation is peak. So we need to just display. So what is the use of this operation is, just to display data element present at the top point of stack, at top location, whatever the data is present, we need to display or view the data. So what we can say, if top is equal to -1, we need to print that no element is present in stack. In any other situation, we need to display the element present in the top in the stack. So print f %d, or we can write this way: top element present is top element data is %d s of top. So this is about the peak or top function or operation. Next is display. So let's say I have all the elements, let's say 40. So this is not filled, currently top is here. So 0, 1, 2, 3, 4. So top is here. I want to display all the elements. Let's say I want to display in this fashion. We can also display in this fashion. It's our wish. So I want to display elements in any order of our wish. So currently what I want to do is I want to display the elements in this fashion. So I want to display the elements in this fashion. So what I will be doing is I will be writing a for loop. Before it also we need to check one thing. If there are no elements, we need to print it, right? So if top is equal to -1, we need to print that. So no element is present in stack. No element is present in stack. In any other situation, we should be printing. So let me take a temporary variable like int I is equal to 0, I less than or is equal to top, I plus plus. So what I need to print? So elements are elements in stack. Stack are %d slash n. So s of I. So in each line, one after one, all the elements will be printed. So this is about the void function. So next is search. Void search. So I want to search a particular element in the stack. So here also we need to check this condition. If top is equal to -1, printf stack is empty. That is no element is present. In any other situation, so before it, so else is the situation, will be asking, so printf enter search data element, means what element we need to search. So let's say I want to search 30. Scanf %d ampersand let's say x. Let me define x, int x. Okay, so I will be searching the element one by one. For int I is equal to 0, I less than is equal to top, I plus plus. Now what I will be checking, if, so for I will be writing this: if a of s of I is equal to x, if it is found, so it will be checked recursively. If s of I is equal to x, then we'll be breaking, else printf element is not present. So this is the searching. So how it operates, let us see. So here I want to check for 30, right? I want to check for 30. So let us consider this one, this as only our stack. So printf enter data. So as top is not equal to -1, it will not go into this, so it will go into else loop. So enter search element, will entering 30. So int I is equal to 0, I less than top, I plus plus. So here I is equal to 0, I less than or is equal to, here top is at 3, right? I plus plus. So initially I is equal to 0. So stack of 0 is equal to, it will be checking for 30. So as it is not true, so it won't go into this. Then it will, I think we should be writing it's outside. So for this condition to check if the element is not present, so let's modify the code in a little way. Okay, so if s of I is equal to x, means if data is found, then what will be printing is printf data is found at index I, and I will be using the break statement. Before it I will be also, let's say, use the flag is equal to 1. So int flag I will initialize it to 0. Okay, so now I will close. So in this for loop only I will be writing if a flag is equal to 0, then what we can do, printf element is not present in this stack, such element is not present in the stack. So now we can close. So this is how it can basically search a particular element, the data element is present in the current available stack or not. So up to now what we have seen is push operation, we have saw pop operation. Push means insert operation, pop means delete operation. We also saw the search operation, display operation, and also the top operation. So these are the fundamental operations that are available in the stack. We will be also looking at the practical implementation of stack using the arrays. Before closing the session, once let us look at the time complexities of each operation. So before that there is a simple trick, right? If we are not using any for loop, the complexity will be order of 1. If we are using one for loop, the order of complexity, the time complexity will be order of n. If we are using for loop within a for loop, then the time complexity will be order of n square. So we'll see. So for searching we are using only one for loop, so the time complexity is order of n. For display we are using basically one for loop, so the complexity is order of n here also. And for peak or top operation we are not using any for loop, so order of 1. And even for pop we are not using any for loop, so here also it is order of 1. And here also for push we are not using anything, so here also it is order of 1. So for push, pop, and also for search, for these three it is order of 1, and for display and top it is order of n.